Hello friends and dear students. Today in continuation with biomolecule topic, I am going to discuss about chemical structure of monosaccharides. You know biomolecules that includes carbohydrate, protein, fat, vitamins and nucleic acid. So today I am going to discuss about the chemical structure of carbohydrate. You know carbohydrate, that is aldehydic or ketonic form of polyhydroxy alcohol. So first of all, you know it is the monosaccharides, that is the simplest sugar among all these categories. Like if you divide carbohydrate in 3 units, then monosaccharides, that is the monomeric units, and oligosaccharide means few units of monosaccharide, 2, 2, 6 or 7. Okay, and then polysaccharides means more than 10 units of monomeric carbohydrate, that is it may be glucose or any monosaccharides. So now today I am going to discuss how to draw chemical structure of monosaccharides. So this is a symbolic representation, that is E. So this E means, suppose this is G. So this G is glyceraldehyde. This is G is glyceraldehyde. This is 3 carbon containing monosaccharides. And we indicate for learning GO means all the hydroxy group present on right side. This is glyceraldehyde. Glyceraldehyde. Okay. Next, that is 4 carbon containing monosaccharides. That is erythrose and triose. E means erythrose. It means O indicate or 0 indicate all the hydroxy group in a straight chain present on right side. And then that is in case of triose, it is also 4 carbon containing monosaccharides. So in this case, carbon number 2, if you start from aldehyde, that is carbon number 1, the hydroxy group present at left side. So just to learn, just to recall, I am discussing these things. So next category, that is 5 carbon containing monosaccharides. So this is R. R means ribose. And then A means Aminos. And then X means Yadav, and then L means Aldoses. So these all are 5 carbon containing monosaccharides. Means R means R, A, X, L. So this is 5 carbon containing monosaccharides. So that in case of 5 carbon containing monosaccharide, this ribose contain all the hydroxy group on the right side. In case of Aminos, the carbon number 2, the hydroxy group present at the left side, rest all other hydroxy group present on right side. In case of Gyrose, carbon number 3, the hydroxy group present on the carbon number 3 is left side. In case of Gyrose, at carbon number 2 and carbon number 3, hydroxy group present on left side. But these all are 5 carbon containing monosaccharides. Next is 6 carbon containing monosaccharides. So this is A, G, M, G, I, G, T. So this is Aldose. This is Aldose. This is Aldose. This is glucose glucose, glucose, and this is iodine, iodose, and this is galactose, galactose, okay, and this is Tetroses. So these are 6 carbon containing monosaccharides. So if you want to recall in what carbon the hydroxy group left side or right side. So 0 indicate in case of Aldoses all the hydroxy group present on right side in a straight chain. In case of Aldose at carbon number 2 the hydroxy group present on left side. In case of glucose at carbon number 3 hydroxy group present on left side. In case of mannose at carbon number 2 and 3 hydroxy group present on left side. In case of glucose at carbon number 4 hydroxy group present on left side. In case of iodose the hydroxy group at the carbon number 2 and 4 are present on left side. In case of galactose the hydroxy group present at carbon number 3 and 4 are left side. In case of Tetroses carbon number 2, 3 and 4 hydroxy group present on left side. So you have to remember like G, E, T. What do you know G? G means glyceraldehyde, that is 3 carbon containing simplest carbohydrate monosaccharides. And Et means erythrose and triose. This is 4 carbon containing monosaccharides. Then RAXL. This is RAXL means ribose at carbon number all the hydroxy group present on right side. In case of Aminos at carbon number 2 hydroxy group present on left side. In case of xylose carbon number 3 hydroxy group present on left side. And in case of lysose carbon number 2 and 3 hydroxy group present on left side. So you have to remember like RAXL. Then Agam-Gi-Gat. Agam-Gi-Gat. Just to remember, this all monosaccharides. So this is 3 carbon containing monosaccharides. This is 4 carbon containing monosaccharides. This is 5 carbon containing monosaccharides. This is 6 carbon containing monosaccharides. Now let us start with the chemical structure from the beginning, that is the simplest carbohydrate, that is glyceraldehyde. Now you have to draw simple a chain of 3. Simple, you have to draw a chain of 3. In case of carbon number 1, 2 and 3, you have to show aldehyde. You have to show aldehyde. Okay. So this is aldehyde. This is aldehyde. You know 1, 2, 3, 4. And then you draw hydroxy group like that. Okay. That. So this is the simplest carbohydrate and that is glyceraldehyde. This is the chemical structure of glyceraldehyde. So this is, you have to draw easily. You draw a chain of 3 carbon, 1, 2, 3. So this is the carbon number 1 must contain the aldehyde group. This is aldehyde group. Aldehyde. So in case of aldehydic sugar, I am discussing the chemical structure of aldehydic sugar. So the carbon number 1 must contain aldehyde group, rest there is a hydroxy group at carbon number 2 and 3. So I am indicating the GO. It means no other hydroxy group present at left side. Next, if you draw the structure of 4 carbon containing monosaccharides. So it is simple. You have to draw like that. Okay. So you have in the carbon number 1. This is the carbon. Suppose this is carbon number 1. So you have to indicate aldehyde. You have to indicate aldehyde. And in the same way, in the second, you have to indicate aldehyde. Now, how can you differentiate erythrose and triose? So I have already written GO, means all hydroxy group on the right side. On the rest other carbon like carbon number 2, 3 and 4. So draw like that. So this is hydroxy group. This is hydroxy group. Okay. Rest, you know carbon have 4 valency, so you have to indicate hydrogen, hydrogen, hydrogen like that. So this is the chemical structure of erythrose. Erythrose. Okay. Now, if you differentiate between erythrose and triose, I am drawing the chemical structure of triose. So you know I have indicated 2. It means at carbon number 2, hydroxy group present on left side. Okay. Rest other carbon hydroxyl group present on right side. Okay. So you have to fulfill the valency of carbon. Carbon has 4 valency, oxygen has 2 valency, hydrogen has 1 valency. So you have to draw like that. This is the simple drawing of this chemical structure of what? That is triose. So this is the triose. Okay, triose. So this is 4 carbon containing monosaccharides. If you see the difference is only on carbon number 2. What is difference? In case of triose, the hydroxy group is present on the carbon number 2. In case of erythrose, hydroxy group present on the carbon number 2 on the right side. But in case of triose, hydroxy group present on the left side. Okay. So this is the simple drawing of chemical structure of triose and erythrose. So I have discussed the chemical structure of glyceraldehyde, chemical structure of erythrose, chemical structure of that is triose. Okay. So try to differentiate. How can you differentiate this erythrose and triose? Only position of hydroxy group at carbon number 2. Next, I am going to proceed for the chemical structure of 5 carbon containing monosaccharides. Okay. So let's start the drawing of 5 carbon containing monosaccharides. Okay. So simply you have to draw a chain of 5 carbon like that. 1, 2, 3, 4, 5. Simple. Okay. Next, you have to draw chain of again 5 carbon containing monosaccharides. Simple. Again 5 carbon containing monosaccharides. Okay. This is 3, and next also you can draw easily. You can join the C. Okay. This indicates the carbon. Okay. So there is a 5 carbon 1, 2, 3, 4, 5. In each chain, on the carbon number 1, you have to draw a aldehyde. This is aldehyde. This is the simple aldehyde. Again, you have to draw a simple aldehyde. Okay. So this is again you can draw simple aldehyde. Okay. Now I have told you that you have to remember 0, 2, 3 and combination of 2, 3. So you have to write here 2, 3. Simple sequence 0, 2, 3 and combination of these 2, 2, 3. So I am drawing the structure of ribose, simplest 5 carbon containing monosaccharides. So you have to draw easily. You have to put hydroxy group in the simple way. Okay. So just see the simply you put the hydroxy group. You have to fulfill the valency of the carbon. In case of carbon number 2, you have to add 1 hydrogen, 3 1 hydrogen, 4 1 hydrogen. But in carbon number 5th, because carbon has 4 valency, so you have to add 2 more hydrogen. So now this is the straight chain of chemical structure of ribose. Now if you want to draw the structure of Aminos, so this is ribose. This is ribose. Now I want to draw the chemical structure of Aminos. So what is the difference between ribose and Aminos? Just remember 2, 0, 2, 3, 2, 3. Means simply you remember like 0, 2, then 3, and combination of this 2, that is 2, 3. Okay. So I am going to start drawing the chemical structure of Aminos. So you have to remember 2. 2 means at carbon number 2 you have to indicate hydroxy group. Okay, like that. And then rest other carbon you have to draw hydroxy group like that. Okay, and then you have to draw like that. Now you have to fulfill the valency of carbon. How? By putting simple hydrogen. Okay, so this is I am putting the hydrogen. Okay, and then in case of every fifth carbon, last carbon, you have to add more number of hydrogen, means 2 hydrogen. So this is chemical structure of Aminos. If you differentiate, then you have to differentiate at carbon number 2. If you see the ribose hydroxy group present on the right side at carbon number 2. In case of Aminos, hydroxy group present at left side. Yes. So go and do your work as per drawing the chemical structure. Okay. So you know, in case of Aminos, you know there is a difference at carbon number 2 only. So carbon number 2 means hydroxy group on the right side in case of ribose, and hydroxy group at the left side in case of Aminos. Now I am going to draw the chemical structure of xylose. There is a you have to remember 3. So what is 3? Means at carbon number 3, 1, 2, 3, you have to draw hydroxy group left side. Yes, and then rest other carbon you have to draw hydroxy group simple right side. Okay, then you have to fulfill the valency. On the each carbon. Okay, so this is a chemical structure of that is xylose. Xylose is 5 carbon containing monosaccharides. Okay, so you remember that in every exam, whether it is a engineering test or whether it is a medical test, somehow the question will ask from the chemical structure of monosaccharides. So let's try to learn how can you draw easily the chemical structure of all the monosaccharides. So I have already drawn the xylose. That is, there is a difference. Where you find the difference? On carbon number 3. On carbon number 3, you will find the difference. Let's start the chemical structure of lysose. Lysose. This is also a 5 carbon containing monosaccharides. So I have told you that you have to remember the sequence 0, 2, 3, 2, 3. So you have to remember in this case 2, 3. What do you mean by 2, 3? 2, 3 means 1, 2. 2 at the carbon number 2, you have to draw hydroxy group left side. Again, at carbon number 3, hydroxy group indicate on the yes.
The image is like that.
Yes. Okay. Yes. So all of you, you have to draw at carbon number 2, carbon number 3, hydroxy group at the left side, and the rest of the carbon you have to indicate hydroxy group on the right side. Okay. So you have to join the bonding with O, not H. It is wrong if you draw like that. If you draw like that, then it is wrong, because hydrogen have no valency 2, but oxygen has valency 2, so you have to draw like that. Okay, so this is it. Now you on each carbon you have to fulfill the valency by putting hydrogen. So this is hydrogen, this is hydrogen, and this is hydrogen. So this is the overall structure of 5 carbon containing monosaccharides, that is ribose. In this case, all the hydroxy group on the right side, so you have to remember 0. In case of aminos, at carbon number 2, the hydroxy group left side, so you remember 2. Okay. In case of Galactose, at carbon number 3, hydroxy group present at the left side, so you have to remember the 3. Okay. In case of Lysos, at carbon number 2 and 3, hydroxy group present on left side, so you have to remember 2, 3. So this is the simple sequence: 0, 2, 3 and 2, 3. Very good. So you have to remember all the structure of the monosaccharide that have 5 carbon. So you have to remember the sequence only: 0, 2, 3, 2, 3. Now I am going to draw the structure of 6 carbon containing monosaccharides. Okay, so let's start with making the carbon chain of 6 carbon. Okay, so you have to draw like that: 1, 2, 3, 4, 5, 6. Okay, again 1, 2, 3, 4, 5, 6. Easy. And then 1, 2, 3, 4, 5 and 6. This is 3. Again you have to draw 1, 2, 3, 4, 5 and 6. Okay. So in the same way you have to draw here also, just to draw all the structure: 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6. Okay, this is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 and 6. Again you can also draw one more: 1, 2, 3, 4, 5 and 6. So I have already discussed about the 6 carbon containing monosaccharide. You have to remember Aldoses, Tetroses, Glucose, Mannose, Glucose, Iodose, Galactose and Tetroses. So get. Okay, so get. You have to remember for remembering 6 carbon containing monosaccharides. Get. You can remember G, ET, RAXL, and then get. Okay, so in this way you have to draw a structure of first Aldose, then Tetroses, then Glucose, then Mannose, then Glucose, then Iodose, then Galactose and then Tetroses. So in all condition you have to draw one more. You have to draw one more chemical structure, that is 1, 2, 3, 4, 5, 6. So in each case 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. Total number of monosaccharides that have 6 carbon, that is 8. Aldose, Tetroses, Glucose, Mannose, Glucose, Iodose, Galactose and Tetroses. Simple. So you have to remember the sequence: 0, 2, 3 and combination of these 2 and 3 you have to write here. Then again we start with 4. Then 4. Then you combine with 2 and 4. 2, 4. 3 and 4. 3, 4. 2, 3 and combination of all, that is 2, 3, 4. Simple. Just to remember in which position hydroxy group present at left side. So simply on carbon number 1 you have to indicate aldehyde. At carbon number 1 you have to indicate aldehyde. Okay, at carbon number 1 you have to indicate aldehyde. Okay, so you can easily draw at carbon number 1, that is aldehyde. Okay, this is simple. Now you have to follow this rule. Geo means all hydroxy group on the right side. All the hydroxy group on the right side. All the hydroxy group on the right side. 1, 2, 3, 4, 5 and 6. Okay. So in that situation you have to draw and then you have to fulfill the valency. You have to fulfill the valency of the carbon. Carbon have 4 valency. So you have to put the hydrogen. So it is the simple structure of allose. This is the simple structure of allose. Okay. Now I am going to next. That is aldose. Aldose. So how can you draw? Just remember 2. Nothing. So you have to draw carbon at carbon number 2 hydroxy group left side. Rest other hydroxy group present on right side. Rest other position hydroxy group present on right side. And then you have to fulfill the valency of carbon. Simple. Okay. This is simple structure of aldose. Allose and aldose. I have already discussed allose and aldose. Their difference at carbon number 2. You can observe the difference at carbon number 2. In case of allose, carbon number 2 hydroxy group present on right side. In case of aldose, at carbon number 2 hydroxy group present on left side. Simple. Next come to glucose. What you have to do? Simply you have to draw a chemical structure that is hydroxy group on left side. Rest other carbon you have to draw hydroxy group on the right side. This is a simple structure. And then you put the hydrogen at each carbon like that. Okay. So this is the chemical structure of glucose. This is glucose. Okay. So at glucose, carbon number 3 hydroxy group on the left side. Next is mannose, not manose, mannose. Okay. So what you have to do? What you have to consider at carbon number 2 and 3. So you count from the top. That is the aldehyde. You start the aldehyde as carbon number 1. Then 2 you have to draw hydroxy group. 3 also hydroxy group left side. Rest other carbon you have to draw hydroxy group right side. So this is the chemical structure of mannose. You have to fulfill the valency with hydrogen. Okay, hydrogen, hydrogen, hydrogen and hydrogen. So this is the structure of mannose. This is the structure of mannose. Okay. Next, you go to draw the chemical structure of glucose. Glucose is also a monosaccharide that has 6 carbon. Okay. So in this case, you have to consider carbon number 4. Where is carbon number 4? 1, 2, 3, 4. So you have to draw hydroxy group left side. Very good. Then on each carbon, you have to draw hydroxy group right side. Okay. So on each carbon, you have to draw hydroxy group right side. Then you have to fulfill the valency of carbon. Valency of carbon is 4. So you have to draw hydrogen, hydrogen, hydrogen and hydrogen and hydrogen. So this is the chemical structure of mannose. This is the chemical structure of mannose. Okay. So this is chemical structure of mannose. And then glucose. Okay. This is the chemical structure of glucose. Glucose. Okay. Next, that is iodose. Next, I am going to draw the chemical structure of iodose. So what you have to remember? Just after remembering the 4, you combine the 4 with 2. So it is 2, 4. Now you have to consider at carbon number 4, 2, that is hydroxy group left side. 1, 2, 3 and again carbon number 4 hydroxy group left side. So then on the rest of the carbon, you draw the hydroxy group right side. You draw the hydroxy group right side. Again, you have to fulfill the carbon valency. Simple. That is hydrogen, then hydrogen, then hydrogen, then hydrogen, and then hydrogen and hydrogen. So this is chemical structure of hydrogen. Okay. Next, that is galactose. I am drawing the chemical structure of galactose. Okay. So just you know, in case of galactose, you have to remember at carbon number 3 and carbon number 4. Okay. So you have to remember where is carbon number 3 and 4? 1, 2, 3, 4. So at carbon number 3 hydroxy group, and at carbon number 3 hydroxy group. Okay. So beside that, in all other carbon, you have to draw hydroxy group on the right side. Okay. So this is simple chemical structure of galactose. You have to fulfill the valency. Okay. By putting the hydrogen. Okay. So this is total chemical structure of mostly all the monosaccharides that have 6 carbons. Okay. Now one carbon left, one monosaccharide that have 6 carbon left, that is Tetroses. Okay. So if you draw the chemical structure of that Tetroses, so that is you have to draw 6 carbon. Simple. Okay. 1, 2, 3, 4, 5, 6. So you have to draw first carbon aldehyde, and then you have to remember that is 2, 3, 4. So on that side at carbon number 2 you have to indicate hydroxy group, and then hydroxy group. Okay. And then rest of the carbon you have to put hydroxy group on the right side. So you have to remember only 2, 3 and 4. And then you have to fulfill the valency. So this is the simplest form of drawing the chemical structure of all the monosaccharides. Okay. In the next day I will discuss about the disaccharides. Thank you and have a nice day.